Number 12. What does number 12 say, please? So the first question says, what is the arc sine of 0.18? And they want you to use your calculator. So your calculator has a hard time handling radians, right? So what I want you to do, well, there's a little bit of wiggle room here. Okay, so you're basically going to run this twice. Once with it in degree mode, right, your calculator in degree mode, and once with your calculator in radian mode. So you should not actually be getting pies for the radian answers. You'll just be getting decimals. So remember, anytime that you calculate anything in here, that's a decimal, you got 4 decimal places, right? So degrees, radians. Let me get my calculator so I can double check along with you. All right, so make sure you're in degree mode. And then you just push second sine, so you get the arc sine on your calculator, and put in 0.18. And what do you get for your degree? So you get 10.3698 degrees, right? So make sure that you're rounding properly, and you're doing everything you're supposed to be doing, right? Look at the bottom right of your screen. Does it say RAD or DEG? So then what you do is you convert your calculator, so you'll push the DRG button right here, until RAD shows up. So you'll push the DRG and you have degrees, radians, and gradients, right? So you go over to radians, hit enter, and then you retype the problem. So arc sine of 0.18, and this time you get 0.180, well, you get 0.1810. Like that, right? Because it's in 8098, so the 8's going to force the 9 up to a 10, so you get 0.181. And that's it. 12 is done. All right, because they're letting you use a calculator, make sure you know how to use your calculators. If you don't, then ask somebody who does and get it figured out, okay? Or look it up, or whatever it is that you need to do. Make sure that you know how to use this tool. Up next, after 12, is number 23. What does number 23 say, please, and thank you? Why is this important? The 180 less than theta less than 270. It tells you which quadrant we're working in. So what quadrant is between 180 and 270? The third, okay? Is my tangent positive or negative in my equation? It's positive, okay? Why do I need to specify? Because there are 2 quadrants where tangent is positive, right? It's positive in the first, and it's positive in the third. So I need to figure out which quadrant we're actually working in. All right, so I'm working in the third quadrant, which means that my theta that I find has to be bigger than 180, but it needs to be less than 270. Everybody okay with that? So when you calculate this on your calculator, you'll see what I'm talking about. So how do I get theta by itself here? What do I have to get rid of to get theta by itself on the left? Tangent. What undoes a tangent? The inverse tangent, or the arctan. All right, so we're going to take the inverse tangent of both sides. So I get inverse tangent of theta equals the inverse tangent of 3.2. So here the tangent, inverse, and tangent cancel. Leaves you with theta. Now, on your calculator, make sure you're in degree mode, please, and calculate the arctangent of 3.2. .646 degrees, right? Yes, please. It'll make the math easier. You technically can do it in radian mode, but you're going to get some weird decimals. Right, and then you're going to add that to a pi. So, okay, 72.646. Is 72.646 degrees between 180 and 270? No, this is a first quadrant answer, right? Because that's what your calculator is based in. Your calculator is designed to try to keep you in either the first or the fourth, because that's where we know the most stuff. Okay? So what that means is that we have to be smarter than the math. This is in the first quadrant. I have to be between 180 and 270, right? So where does my reference angle come from? 180 or 270? Do reference angles come from the x-axis or the y-axis? X. What is my x-axis value? 180. So if I'm looking for 72.646 degrees in the first quadrant, I'm going to do the same amount of movement from 180 to drop me into the third quadrant. So my actual answer is going to be the 180 degree, which is my x-axis bound, plus 72.646 degrees, because this is actually a reference angle for me in the third quadrant. So add these up, and you're going to get 252.646 degrees, and that is your answer, which is between 180 and 270. Do you want me to draw it if that doesn't make sense with just the description? Anybody want to see it drawn out, or are we all right? So for these, this part right here is very, very, very important. Please make sure you're paying attention to it, all right? Because it tells you, again, which quadrant we're working in. So if tangent were negative, there's two quadrants where that can happen. Which answer do I want? Do I want the one in the second quadrant or the one in the fourth? Okay. Here, tangent is positive. Every trig function is positive in two quadrants. So again, which one am I looking for? First quadrant or third? What does number 27 say? Doodar, doodar. Okay. Right triangle or non-right triangle? And they want you to find theta. Okay. So this is where inverse trig functions really come in handy. So first things first, we always look from the angle, right? The angle always determines what's opposite or what's adjacent, all right? Just like we did with our regular right triangle trig. So from theta, what is the relationship between theta and the 5? Is that opposite, adjacent, or hypotenuse? Opposite. What's the relationship between theta and the 8? Hypotenuse, right? It's adjacent, but it's also across from the 90, which makes it the hypotenuse, right? So which trig function relates opposite and hypotenuse? Sine. So what that means is that the sine of theta has to be, whoa, that's not theta, that's sigma. What are you doing? Here you go. The sine of theta has to be equal to opposite over hypotenuse, right? So what's that opposite? And what's the hypotenuse? Okay. So what did the directions ask you to find? Theta. So how do I find theta? Right, so I arc sine, right? Or inverse sine. Everybody okay with that? To get rid of the sine? So I'm going to arc sine the left, arc sine the right. These cancel, and I get theta is equal to whatever the arc sine of 5/8 is, which in degrees is going to be 38.6822 degrees. Okay, so what we were doing with right triangle trig is if I gave you the three sides, right? Or sorry, if I gave you an angle and two sides, or an angle and a side, you can find everything else, right? So now what we're doing is if I give you the sides, you can now find the angles. So now you should be able to solve any right triangle. So regardless of how I pair it up, if it's a right triangle, you should be able to find all three sides and all three angles using your right triangle trigonometry. Okay? And that's really what trig is done to do. It's used to find unknown lengths of triangles. So any ideas on what to do here? Well, how about this? I'll tell you the answer, and you can see if you can figure out where the heck I got it from. The answer is 1 over x. Any ideas at all? So, okay. So if you look at this, do I have any trig functions at all? Okay, so I'm going to do something over there that gets all of my trig to cancel out. The main thing is, do I have an inverse sine up here? No. So what's the only thing that can cancel with an inverse sine? A sine, which means that I can't touch this inverse sine, so I have to look at cosecant, right? Can I write cosecant as something with sine? Not opposite, but the reciprocal. So cosecant is actually equal to what? So if I just give you cosecant of x, that's actually equal to what? 1 over sine of x. They're reciprocals of each other. 1 over cosecant is sine, 1 over sine is cosecant. Everybody okay with that? So what I'm going to do is I'm going to flip it. So what's cosecant really equal to? 1 over the sine, like that. Everybody okay with what's going on or no? Because cosecant includes this sine, inverse sine of x, so it's just going to come down. So all I did was change cosecant into 1 over sine. Okay? So what's sine of inverse sine? What do they do with each other? They cancel out. So what's left? Just the x, and you get 1 over x.